GCE O Level Mathematics, Lecture 19, Simple Linear Inequalities. Hello everyone, Dennis here. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Here are the learning objectives of this lecture. There are a few things we want to learn from inequalities. The first one is to understand the idea of inequalities, followed by understand inequality signs and properties, then understand 4 rules of inequalities so that we can use these rules to solve inequalities. Then we'll discuss a few examples and solve linear inequalities in one variable. We can further discuss to solve simultaneous linear inequalities in one variable, and lastly, to find largest and smallest values of variables given the range of the values of x and y. Idea of simple linear inequalities. Let's see this example. A pen costs $1.50 and I have a $10 note. Question: how many maximum number of pens can I buy? Let's see how we can work it out. First, let x equals number of pens I can buy. Hence, total I need to pay to buy x pens will be $1.50 times with x, which is 1.5x. Now let's compare 1.5x with 10. So it has to be less than or equals to 10. So x will be less than or equals to 10 over 1.5, which is 6 2/3. Therefore, the answer is the maximum number of pens I can buy is 6. Now, let's check the answer. So if I buy 6 pens at $1.50 each, so the total will be $9, which is less than $10. If I buy extra 1 more pen, then the total I have to pay will be $10.50, which is more than $10. Hence, the maximum number of pens I can buy is 6. Understanding inequality signs. First, we start with recognizing the signs. So this sign means less than. This sign means more than. This sign means less than or equals to. And this sign means more than or equals to. Here is the number line. We start from 0. The numbers at the right hand side of the zeros are positive numbers. From here, 1 is less than 2 or 2 is greater than 1. Similarly, 4 is less than 5 or 5 is greater than 4. The numbers at the left hand side of zeros are negative numbers. So from here, we can say that negative 2 is less than negative 1 or negative 1 is greater than negative 2. Similarly, negative 5 is less than negative 4 or negative 4 is greater than negative 5. As you can see from here, the numbers towards the left hand side is smaller and the numbers towards the right hand side are greater. If x is an integer and x is less than 2, then the possible value of x will be 1, 0, negative 1, negative 2, and so on. If x is less than or equals to 2, then the possible value of x will be 2, 1, 0, negative 1, negative 2, and so on. As you can see from here, 2 is inclusive in this example. So if x is in the range of -2 to 2, then the possible value of x will be -1, 0, and 1. If x is in the range of -2 and 2 inclusive, then the x possible value will be -2, -1, 0, 1, and 2. And again, as you can see from this example, -2 and 2 are inclusive. So let's discuss negative inequalities. If -3 is less than 2, then 3 is greater than -2. Similarly, if -x is less than 2, then x is greater than -2. If -3 times 2 is less than 2, then 3 times 2 is greater than -2. If -3 times x is less than 2, then 3 times x is greater than -2. So from here, we can see how inequality sign switches direction. So inequality sign must switch its direction when positive or negative signs have changed. However, the position of the numbers or x term do not change. So we will need to remember this concept because we need to use it to solve inequalities. Next, we will discuss some properties of inequalities. Given A, B, and C are real numbers, property number 1, which is called transitive property. If A is less than B and B is less than C, then A is less than C. So to explain this property, let's look at this number line. So this is A, this is B, and this from here we can say that A is less than B. So this is C, and from here we can say that B is less than C. Hence A is less than C, as A is at the left hand side and C is at the right hand side. So as we have understood from the previous page, the numbers towards the left is smaller and the numbers towards the right is greater. Next, property number 2, which is called addition property. If A is less than B, then A plus C is less than B plus C. So does this look familiar to you? Yes. This property is similar with the property we have discussed in solving linear equations. So here's an example. If x minus 2 is less than 3, then x minus 2 plus 2 is less than 3 plus 2. So for this case, we add 2 for both sides, and we get x is less than 5. You can see this case as if you are moving minus 2 to the right hand side, and it becomes plus 2. Property number 3 is called subtraction property. If A is less than B, then A minus C is less than B minus C. So here's an example. If x plus 2 is less than 3, then x plus 2 minus 2 is less than 3 minus 2. So for this case, we minus 2 for both sides. And the result we get is x is less than 1. So you can treat this example as you want to move this plus 2 to the right hand side, and it becomes minus 2 at the right hand side. Property number 3 is called multiplication property. If A is less than B and C is positive, then A times C is less than B times C. Here's an example. If x over 2 is less than 3, then x over 2 times 2 is less than 3 times 2. So for this case, we times 2 for both sides. We can cancel the 2 here, and the result we get is x is less than 6. So for this case, we can treat it as we move the 2 from the left side to the right side, so it becomes multiply. If A is less than B and C is negative, then A times C is greater than B times C. As you can see, for this case, when C becomes negative, we have to switch the inequality sign. So here's an example. If x over negative 2 is less than 3, then x over negative 2 times negative 2 is greater than 3 times negative 2. Then, for this case, we times negative 2 for both sides. Then cancel this negative 2. We get the result is x is greater than negative 6. So for this example, we can treat it as moving the negative 2 to the right side. From division becomes multiplication. Property number 4 is also called division property. So in this property, if A is less than B and C is positive, then A divided by C is less than B divided by C. Here's an example. If 2x is less than 3, then 2x over 2 is less than 3 over 2. So for this case, we divide 2 for both sides. Cancel the 2 here, and the result is x is less than 3 over 2. So we can treat this case as moving the 2 from the left side to the right side. So from multiplication becomes division. If A is less than B and C is negative, then A divided by C is greater than B divided by C. As you can see from here, when C is negative, the inequality sign has to switch as well for division. So here's an example. If negative 2x is less than 3, then negative 2x over negative 2 is greater than 3 over negative 2. So for this case, we divide negative 2 for both sides. So we cancel the negative 2, and the result is x is greater than negative 3 over 2. So for this example, we can treat it as moving the negative 2 from left hand side to right hand side, and it becomes division. After discussing all the properties of inequalities, here is the summary of the 4 rules that we need to follow to solve inequalities. Rule number 1, the addition rule. If x plus b is less than c, then x is less than c minus b. Example, if x plus 2 is less than 6, then x is less than 6 minus 2, which is x is less than 4. Rule number 2, the subtraction rule. If x minus b is less than c, then x is less than c plus b. Example, if x minus 2 is less than 6, then x is less than 6 plus 2, which is x is less than 8. Rule number 3, the multiplication rule. A. If bx is less than c and b is positive, then x is less than c over b. Example, if 2x is less than 6, then x is less than 6 over 2, which is x is less than 3. B. If bx is less than c and b is negative, then x is greater than c over b. As you can see from here, the inequality sign will switch its direction if b is negative. Example, if negative 2x is less than 6, then x is greater than 6 over negative 2, which is x is greater than negative 3. Rule number 4, the division rule. So this rule is very similar with multiplication rule. A. If x over b is less than c and b is positive, then x is less than c times b. Example, if x over 2 is less than 6, then x is less than 6 times 2, which is x is less than 12. B. If x over b is less than c and b is negative, then x will be greater than c times b. And again, from here, as you can see, the inequality sign will switch its direction when b is negative. Example, if x over negative 2 is less than 6, then x is greater than 6 times negative 2, which is x is greater than negative 12. Do take note that all these four rules are applicable to other inequality signs as well. Now, let's learn how to represent inequalities on a number line. We know that there are four symbols of inequalities, which are less than, greater than, less than or equals to, and greater than or equals to. So let's see the first one. X is less than a. So to represent this, we will have to find the point A, and since it is less than, so we will draw a circle or a white dot, then draw an arrow pointing to the left hand side. So this shows that it is x less than the value a. For example, if x is less than 2, then this is how the number line looks like. So at number 2, we draw a circle or a white dot, then an arrow pointing to the left to show that the value of x is less than 2. If x is greater than a, then at number a, we draw a white dot pointing to the right, which shows that x is greater than a. Example, let's say x is greater than 2, then at number 2, we draw a white dot and an arrow drawing to the right hand side. So this represents x value is greater than 2. Now what about the symbol which is x less than or equals to a? So on the number line, at number a, we draw a black dot, right? And then point to the left hand side, the arrow. So this shows that the x is less than or equals to a. So the black dot means inclusive of a. If it is a white dot, that means it is not inclusive of a. Example, x is less than or equals to 2. Then on the number line, at number 2, we draw a black dot, point to the left hand side, the arrow. So this represents x is less than or equals to 2. On the other hand, if x is greater or equals to a, so on number a, we draw a black dot, point to the right hand side. So this shows it is x is greater than or equals to a. Example, x is greater or equals to 2. Then on number 2, we draw a black dot, the arrow point to the right hand side. So this shows that x is greater or equals to 2. After understanding the inequalities properties, the four rules, and how to represent inequalities on number line, let's see some examples and learn how to solve linear inequalities in one variable. Example 1. Solve the following inequalities. Represent the answers on a number line. A. 3x plus 2 is greater than or equals to 14. B. 5x minus 7 is less than or equals to 23. C. X over 6 plus 7 is greater than 25. D. 4x over 5 minus 5 less than 19. Here is a solution for A. 3x plus 2 greater or equals to 14. So the first thing we have to do is we move the plus 2 from left side to right side, becomes minus 2, and we get 3x is greater or equals to 12. Then we move the 3 from left side to the right side, it becomes divide. So x is greater or equals to 12 over 3, then the result is x is greater or equals to 4. And now let's represent this on a number line. At number 4, we draw a black dot, and since it's greater than 4, so we point to the right side, the arrow. Okay, now move on to B. 5x minus 7 is less than or equals to 23. So we move the minus 7 to the right side, become plus 7. So 5x is less than or equals to 30. Now we move the 5 to the right side, becomes divide. So x is less than or equals to 30 over 5. And we get the result. X is less than or equals to 6. And now let's represent it on the number line. So at number 6, we draw a black dot, and since it is less than or equals to, so the arrow will point to the left. Okay, next, see x over 6 plus 7 is greater than 25. So the concept is very similar. First move the plus 7 to the right side, becomes minus 7. Hence x over 6 is greater than 80. Now, since x over 6 means x divided by 6, we move the 6 from left hand side to the right side, it becomes multiply. So x is greater or equals, x is greater than 18 times 6, which is the result x greater than 108. Okay, so on the number line, at number 108, we draw a white dot, and then the arrow point to the right hand side because x is greater than 108. So lastly, D, 4x over 5 minus 5 less than 19. So I move the minus 5 to the right side, become plus 5. Hence 4x over 5 is less than 24. Then the 5 move to the right, becomes multiply, and the 4 move to the right as well, become divide. Hence the 24 will multiply with the reciprocal of 4 over 5, which is 5 over 4. Simplify, we get x is less than 30. So this is the answer for D. And we represent it on number line. At number 30, we draw a white dot because not inclusive of 30. Then the arrow point to the left because it is less than. For C and D, both inequalities involve fractions. So some students may find it uneasy when they handle fractions. So here is another alternative way that you can use to solve these two inequalities. So for C, the inequality is x over 6 plus 7 greater than 25. So what we can do is we multiply 6 for both sides so that we can eliminate the denominator of the fraction. So this is what happened. So 6 times bracket x over 6 plus 7 greater than 25 times 6. Then we expand the bracket, we get x plus 42 greater than 150. Now this inequality is easy to solve. Just move the plus 42 from left side to right side, becomes minus 42. Hence x is greater than 108. For D, 4x over 5 minus 5 less than 19. So what we can do is we multiply 5 for both sides so that we can cancel out the denominator of 5. So this is what we have. 5 times bracket 4x over 5 minus 5 less than 90 times 5. Expand the bracket, we get 4x minus 25 less than 95. Now this is much easier to solve. Move the minus 25 to the right side, become plus 25, hence 4x is less than 120. And now move the 4 to the right side, becomes divide. X is less than 120 over 4, hence x is less than 30. Try it yourself. 1. Solve the following inequalities. Represent the answers on a number line. A. 7x plus 5 is less than 68. B. 11x minus 9 is greater than 35. C. 2x over 3 plus 8 is greater or equals to 22. And D. X over 13 minus 6 is less than or equals to 1. You can pause the video and try to solve it yourself. Alright, here's the solution. For A, 7x plus 5 less than 68. We move the plus 5 to the right hand side, becomes minus 5. Then 7x is less than 63. Now we move the 7 to the right side, becomes divide. So x is less than 63 over 7. Hence the answer is x is less than 9. And now represent this on a number line. At number 9, we draw a y dot and point to the left-hand side. So for b, 11x minus 9 is greater than 35. So move the minus 9 to the right side, becomes plus 9. And 11x is greater than 44. Now move the 11 to the right side, becomes divide. X is greater than 44 over 11, which we get x is greater than 4. And now represent it on a number line. At number 4, we draw a y dot because now there is no inclusive. Then point to the right side as it is greater than 4. So C, 2x over 3 plus 8 is greater or equals to 22. Move the plus 8 to the right side, becomes minus 8. Hence 2x over 3 is greater or equals to 14. Then move the 2 over 3 to the right side, becomes reciprocal. So x is greater than 14 times 3 over 2. And we get 21. So x is greater than or equals to 21. Now represent it on a number line. At number 21, we draw a black dot and the arrow point to the right side because it is greater or equals to 21. For D, x over 13 minus 6 is less than or equals to 1. So again, we move the minus 6 to the right side, becomes plus 6. So we get x over 13 is less than or equals to 7. And x less than or equals to 7 times 13, which is x is less than or equals to 91. Hence, at number 91, we draw a black dot and the arrow point to the left-hand side. Again, for C and D, they involve fractions. If you are uneasy to handle with fractions, you can apply the alternative method. So for C, 2x over 3 plus 8 is greater or equals to 22. What we can do is we multiply 3 for both sides. So we get 3 times bracket 2x over 3 plus 8 greater or equals to 22 times 3. Then expand the bracket, we get 2x plus 24 greater or equals to 66. Then move the plus 24 to the right side, becomes minus 24. We get 2x is greater or equals to 42. Then move the 2 to the right side, becomes divide. So x is greater or equals to 21. For D, x over 13 minus 6 is less than or equals to 1. So we multiply 13 for both sides. We get 13 times bracket x over 13 minus 6 is less than or equals to 1 times 13. Expand the bracket, we get x minus 78 less than or equals to 13. Now move the minus 78 to the right side, becomes plus 78. Hence, it is x is less than or equals to 91. Example 2. Solve the following inequalities. Represent the answers on a number line. A. 2 minus 3x is greater or equals to 14. B. 7 minus 5x is less than or equals to 23. C. 7 minus x over 6 is greater than 25. D. 5 minus 4x over 5 is less than 19. Alright, so for this example, you have to be very careful because all the x terms here are negative. So the first one, negative 3x. The second is negative 5x. C is negative x over 6. And the D x term is negative 4x over 5. Okay, so to solve these inequalities, there are two methods you can use, either of the method. So the first method is we don't have to switch the inequality sign. The second method, we have to switch the inequality sign. Alright, so you have to learn when you need to switch the inequality sign and when you don't have to switch the inequality sign. Alright, so let's learn it with these examples. For A, 2 minus 3x is greater or equals to 14. So now I'm going to show you the first method, which we don't have to switch the inequality sign. So what we have to do is we have to make the x term to be positive by moving this x term, negative 3x, right to the right side becomes plus 3x. Alright, so now becomes 2 is greater or equals to 14 plus 3x. Okay, the next step, we move the 14 to the left hand side, becomes minus, so it becomes 2 minus 14 is greater or equals to 3x. Then we get negative 12 is greater or equals to 3x. So negative 12 over 3 is greater or equals to 3x, which is negative 4 is greater or equals to x. Alright, and usually we want to make x the subject, so we write the x term first. X is less than or equals to negative 4. Okay, so now we can draw on a number line. At number negative 4, we draw a black dot, and since it's less than, so we draw an arrow pointing to the left. So this is the first method to solve this type of inequalities without switching the inequality sign. Now let's look at B, right, where I will show you this is the example where we need to switch the inequality sign. So what we have to do is, right, we instead of moving minus 5x to the right side, we move the 7 to the right side. So it becomes negative 5x less than or equals to 23 minus 7, which we get negative 5x is less than or equals to 16. And now we want to move the minus 5 to the right side, becomes divide. But take a look for this step. As you can see, the inequality sign has switched the direction. Alright, so why? Because as you can see, right, there are two conditions must be met. The first condition is the sign for the x term has changed from negative to become positive. And the second criteria is the position of the x does not change. As you can see here, after to the next step, right, the x term is still at the left-hand side. Okay, so if these two criteria are met, then you have to switch the inequality sign direction. Compared to the first example here, as you can see, even though the x term has changed the sign from negative to positive, right, but the position of the x has changed from the left side to the right side. Hence, we don't have to switch the inequality sign. Alright, I hope you can see the difference between these two methods. So after that, right, we simplify. We get x is greater or equals to negative 3 and 1 over 5. Okay, next we can represent it on a number line. At number negative 3 and 1 over 5, we draw a black dot and the arrow point to the right hand side because it's greater or equals to negative 3 and 1 over 5. Okay, now the next example, C. 7 minus x over 6 is greater than 25. So now I will use the first approach again, right? I move the minus x over 6 to the right side, becomes plus x over 6. Then I move the 25 to the left side, becomes minus. Hence it is 7 minus 2x. 7 minus 25 greater than x over 6, which is negative 18 is greater than x over 6. Next, move the 6 to the left side, becomes multiply. Hence, negative 108 is greater than x. And again, we usually make x the subject. So we have to rearrange this inequality. X is less than negative 108. Okay, so now drawing on the number line at negative 108, we draw a white dot and the arrow point to the left hand side. Okay, so again for example C, I use the first method, which we don't have to switch the inequality sign direction. For D, again I will repeat with the second method, which we have to switch the inequality sign. So 5 minus 4x over 5 is less than 19. Right, so what we can do is we move the 5 to the right side, becomes minus 5, but the x term is still negative 4x over 5. So it is less than 14. Now this is negative 4 over 5, right? We move to the right side, becomes reciprocal. So 14 times negative 5 over 4. And at this step, as you can see, we will switch the inequality sign direction, because it meets the two criteria. The first criteria, again, the sign of the x term has changed from negative to positive. And second, the position of the x term still remain the same. Alright, so before and after, the x term is still at the left-hand side. Hence, for this case, we have to switch the inequality sign here. Right? So simplify, we get x is greater than negative 35 over 2. So put into improper fraction, proper fraction. So x is greater than negative 17 and a half. Next, draw it on a number line at negative 17 and a half. Draw a white circle and point to the right as it is greater than. Again, for C and D, they involve fractions, right? So we can use the alternative method. So for C, 7 minus x over 6 is greater than 25. What we can do is we multiply 6 for both sides so that we can change the fraction to become a whole number. So now we get 6 times bracket 7 minus x over 6 is greater than 25 times 6. Expand the bracket, we get 42 minus x is greater than 150. Okay, so I use the first method where I don't have to change the inequality sign. So I move the minus x to the right side, becomes plus x. Okay, simplify. We have negative 108 is greater than x. Or we want to make the x a subject, so we write x first. X is less than negative 108. For D, 5 minus 4x over 5 less than 19. So what we can do is we multiply 5 for both sides. We get 5 times bracket 5 minus 4x over 5 less than 19 times 5. Expand the bracket, we get 25 minus 4x is less than 95. Alright, I will use the second method, right, so that I can retain the x term at the left hand side by moving the 25 to the right hand side becomes minus 25. Hence, negative 4x is less than 70. Now I move the negative 4 to the right hand side. And when it comes to this step, the inequality sign have to change as it has met the two criteria. First, the x term has changed the sign from negative to positive, and also the position of the x remain the same, right, which is at the left hand side. So we have to switch the inequality sign from less than to greater than. Then simplify into proper fraction. We get x is greater than negative 17 and a half. Now it's your turn to try yourself. Solve the following inequalities. Represent the answers on a number line. A, 5 minus 7x is less than 68. B, 9 minus 11x is greater than 35. C, 8 minus 2x over 3 is greater or equals to 22. D, 6 minus x over 13 is less than or equals to 1. You can pause the video and try to solve it yourself. Okay, here's the solution. For A, 5 minus 7x less than 68. Alright, so for these four examples, again, they involve the negative x term. Right, so again, I will show you both methods with these four examples here. So A and C, we use the first method. B and D, we use the second method. Okay, so you can practice, or maybe at least you choose one of the methods that you think you like to use it more. Okay, so A, 5 minus 7x less than 68. So move the minus 7x to the right hand side becomes plus 7x. Then 68 move to the left hand side becomes minus 68. We get negative 63 is less than 7x. Then the 7 move to the left hand side becomes divide. So negative 63 over 7 less than x. Hence negative 9 is less than x, or x is greater than negative 9. Then represent on a number line. At number negative 9, we draw a white dot and the arrow point to the right hand side. For B, 9 minus 11x is greater than 35. So instead of moving minus 11x to the right side, we move the 9 to the right side, becomes minus 9, and we get negative 11x is greater than 26. Next, move the negative 11 to the right side, becomes divide, x is less than 26 over negative 11. As you can see from here, we have to switch the inequality sign as the two criteria are met. The sign of the x term has changed from negative to positive, and the position of the x term remain the same, which is at the left side. Alright, so change to proper fraction, x is less than negative 2 and 4 over 11. Then represent on the number line, negative 2 and number negative 2 and 4 over 11. We draw a white dot and point the arrow to the left hand side. Okay, for C, 8 minus 2x over 3 greater than or equals to 22. So I use the method 1 again without switching the inequality sign. So the minus 2x over 3 move to the right side becomes plus. Then the 22 move to the left hand side becomes minus. Hence, negative 14 is greater or equals to 2x over 3. Then move the 2 over 3 to the left hand side becomes reciprocal. Negative 14 times 3 over 2 is greater or equals to x. Simplify. Negative 21 is greater or equals to x. Or make x a subject. X is less than or equals to negative 21. Then draw on the number line at number negative 21. We draw a black dot and the arrow point to the left. For D, 6 minus x over 13 less than or equals to 1. So I use the second method, right? So move the 6 to the left side becomes minus. So there we get negative x over 13 is less than or equals to negative 5. Now we move the 13 to the right side becomes multiply. And as you can see from here, we have to switch the inequality sign because again, it has met the two criteria. The sign of the x term has changed from negative to positive, but the position of the x does not change. It is still at the left hand side. Okay, so we have to switch the inequality sign, and we get x is greater or equals to 65. At number 65, we draw a black dot and the arrow point to the right. Okay, since C and D, they are fractions, we can use the alternative method if you don't like fractions. So for C, 8 minus 2x over 3 greater or equals to 22, we can multiply 3 for both sides. We have 3 times bracket 8 minus 2x over 3 greater or equals to 22 times 3. Expand the bracket, we get 24 minus 2x is greater or equals to 66. Now, we move the minus 2x to the right side, right? As you get 24 greater or equals to 66 plus 2x, then move the 66 to the left hand side. We get negative 42 greater or equals to 2x, then move the 2 to the left hand side, becomes divide. Hence, negative 21 is greater or equals to x. Or rewrite it so that x is the subject. X is less than or equals to negative 21. For D, we can multiply 13 for both sides. Hence, we get 13 times bracket 6 minus x over 13 less than or equals to 1 times 13. Expand the bracket, we get 78 minus x less than or equals to 13. Alright, so now I move the 78 to the left hand side, becomes minus 78. Then we get negative x less than or equals to negative 65. So we want to make x to be positive, and we have to switch the inequality sign because again it meets the two criteria. The sign of the x term has changed from negative to positive, and the position of the x term does not change, which is at the left hand side. Alright, so this is the answer. Let's solve more complicated inequalities. Example 3. Solve the following inequalities. Represent the answers on a number line. A. 4x plus 3 is greater or equals to 2x plus 1. B. 3x minus 5 is less than or equals to 6x plus 7. C. 2x over 5 minus 4 greater than 7x over 15 plus 5. D. 4x minus 5 over 3 less than 2x minus 3 over 4. Here is a solution. For A, 4x plus 3 greater or equals to 2x plus 1. So, to solve this inequality, usually you try to make the x term to be positive. Hence, I will move the 2x to the left-hand side becomes minus 2x, and the plus 3 from the left-hand side, move it to the right side becomes minus 3. Okay, so simplify, we get 2x is greater or equals to negative 2. Now move the 2 to the left-hand side becomes divide, hence x is greater or equals to negative 1. Then represent on the number line and number negative 1. We draw a black dot and draw the arrow pointing to the right. For B, 3x minus 5 is less than or equals to 6x plus 7. So since you want to make the x term to be positive, we will move the 3x to the right side becomes minus 3x, and the plus 7 from the right side move to the left side becomes minus 7. So we have minus 7 less than or equals to 6x minus 3x. We get negative 12 less than or equals to 3x. Right, then move the 3 to the left side becomes divide. Negative 12 over 3 less than or equals to x. Simplify, we get negative 4 less than or equals to x. Or if we move the 6x to the left side becomes minus 6x, and the minus 5 to the right side becomes plus 5. Simplify, we have negative 3x less than or equals to 12. Then move the negative 3 to the right side becomes divide. And for this case, we have to switch the inequality sign because it meets the two criteria. The sign of the x term has changed from negative to positive, and the position of the x does not change, which is remain at the left side. So simplify, we get x is greater or equals to negative 4. Now we can represent it on a number line. At number negative 4, we draw a black circle and point it to the right. For C, 2x over 5 minus 4 is greater than 7x over 15 plus 5. Alright, so since we want to make the x term to be positive, I'll move the 2x over 5 to the right side, become minus 2x over 5, and plus 5 move to the left side becomes minus 5. Simplify, we have negative 9 is greater than x over 15, hence negative 9 times 15 is greater than x, or negative 135 is greater than x. Or we find the LCM of 5 and 15, which is 15. Then we multiply 15 for both sides. Then we expand the bracket. We get 6x minus 60 is greater than 7x plus 75. Right, let's try the second method. Now we move the 7x to the left side because minus 7x minus 6x minus 60 to the right side becomes plus 60. Simplify, we get negative x is greater than 135. Now make x term to be positive, but the position of the x term is still remain the same at the left side. Hence we have to switch the inequality sign. So x is less than negative 135. So draw this on the number line. At number negative 135, we draw a y dot and the arrow points to the left. So for D, 4x minus 5 over 3 less than 2x minus 3 over 4. So what we can do is we cross multiply. We get 4 times 4x minus 5 less than 3 times 2x minus 3. Expand the bracket, we have 16x minus 20 less than 6x minus 9. Right, now move the 6x to the left hand side becomes minus 6x. Move the minus 20 to the right hand side becomes plus 20. Simplify, we get 10x is less than 11. Then move the 10 to the right. X is less than 11 over 10. Or change to proper fraction. X is less than 1 and 1 over 10. Next, draw it on the number line. On the number 1 and 1 over 10, we draw a white dot and the arrow points to the left as x is less than 1 and 1 over 10. Try it yourself 3. Solve the following inequalities. Represent the answers on a number line. A. 5 over 8 times 2 plus 3x greater than 1 plus 2x. B. 3 over 7 plus x over 2 greater or equals to 5x over 2 plus 6 and 3 over 7. C. 4x minus 1 over 5x plus 1 is less than or equals to 11 over 16. D. 2x plus 1 over 6 plus 5x minus 1 over 2 less than or equals less than x minus 4 over 3. You can pause the video and try to solve yourself. Alright, here's the solution. For A, 5 over 8 times 2 plus 3x greater than 1 plus 2x. Okay, so I move the 8 to the right side, becomes multiply with 1 plus 2x, but the 5 I still remain it at the left side. After that, I expand the brackets for both sides. I get 10 plus 15x is greater than 8 plus 16x. Alright, so I will move the 15x to the left side to make the x term positive without switching the inequality sign. Right, and the 8 moved to the left side becomes minus 8. So simplify, we get 2 greater than x, or make x the subject, x is less than 2. Then number 9, at number 2, we draw a white dot and the arrow point to the left. For B, 3 over 7 plus x over 2 is greater or equals to 5x over 2 plus 6 and 3 over 7. Alright, so we multiply 14 for both sides because 14 is the LCM of 7 and 2. And expand the bracket, we get 6 plus 7x is greater or equals to 35x plus 90. Then move the 35x to the left side and move the 6 to the right side becomes minus. So simplify, we get negative 28x is greater or equals to 84. So x is less than or equals to 84 over negative 28. Okay, again, for this case, you have to be careful because the inequality sign of the x term has changed, but the position of the x term does not change. Alright, simplify, we get x is less than or equals to negative 3. Next, represent on the number line at number negative 3, we draw a black dot and the arrow points to the left. For C, 4x minus 1 over 5x plus 1 is less than or equals to 11 over 16. So what we can do is we cross multiply. We get 16 times 4x minus 1 less than or equals to 11 times 5x plus 1. Then we expand the bracket. We have 64x minus 16 less than or equals to 55x plus 11. Okay, now I will move the 55x to the left side becomes minus 55x, and minus 16 from the left to the right becomes plus 16. Simplify, we have 9x is less than or equals to 37. So x will be less than or equals to 27 over 9, which is 3. Now draw on the number line. At number 3, we draw a black dot and the arrow point to the left. D, 2x plus 1 over 6 plus 5x minus 1 over 2 is less than x minus 4 over 3. Okay, so To make it simple, we will multiply both sides with the LCM of 2, 3, and 6. So for this case, it is 6. So we have 6 times bracket 2x plus 1 over 6 plus 5x minus 1 over 2 less than bracket x minus 4 over 3, then times 6. So that when you expand the bracket, you can see that all the denominators are eliminated. Right? We have 2x plus 1 plus 15 minus 3 less than 2x minus 8. Then 2x plus 15x minus 2x is less than negative 8 minus 1. So I group the x term to the left-hand side. Simplify, I have 15x less than negative 9. Hence, x is less than or equals to negative 9 over 15. Right? Or simplify, we have x is less than negative 3 over 5. After that, draw on the number line. At number negative 3 over 5, we draw a white dot and the arrow point to the left. Simultaneous linear inequalities. An unknown x sometimes needs to satisfy two or more linear inequalities simultaneously. We need to find common solution to satisfy these inequalities. So let's look at example 4 to get the idea clearer. Solve the inequalities 3x minus 5 less than 10 and 2x plus 3 less than 15. So as you can see in this example, there are two linear inequalities. The first one is 3x minus 5 less than 10 and the second is 2x plus 3 less than 15. So here's the solution. Step 1, we need to find the solution for each inequality. So the first inequality is 3x minus 5 less than 10, hence 3x is less than 15, x will be less than 5. For the second inequality, 2x plus 3 is less than 15, so 2x is less than 12, hence x is less than 6. As you can see here, this x is in two different inequality. The first one is x is less than 5 and second is x less than 6. So step number 2, we need to identify the common solution using number line. So we have to draw the number line here. So let's draw here. The first number is 5 as the first inequality, x is less than 5. So we draw a white dot here and the arrow point to the left. Second, x is less than 6. So at number 6, we draw a white dot and point to the left as well. So this region is x less than 5. This region is x is between 5 and 6. And this region, x is greater than 6. So for this example, this region is overlapped with two arrows. Hence, the solution is x is less than 5. Try it yourself for. Solve the inequalities 5x minus 2 less than or equals 13 and 3x plus 5 less than or equals 29. Pause the video and try to do it yourself. Alright, here's the solution. So remember, step 1, find the solution for each inequality. So the first inequality is 5x minus 2 less than or equals 13. Hence 5x is less than or equals 15. X is less than or equals 3. The second inequality is 3x plus 5 less than or equals to 29. 3x is less than or equals to 24. Hence x is less than or equals to 8. So next, step number 2, identify the common solution using number line. So let's draw the number line here. This is number 3 and we draw a black dot, the arrow pointing to the left because its x is less than or equals to 3. The second number, x is less than or equals to 8. At number 8 here, draw a black dot and the arrow point to the left. Alright, so remember this region is x less than equals to 3. This region is x between 3 and 8 inclusive. And this region is x is greater than or equals to 8. So for this case, as we can see, this region is overlapped with two arrows. Hence, the solution is x is less than or equals to 3. Now, let's practice more examples. Example 5. Solve the following inequalities. A. 4x plus 5 greater than or equals to 3x plus 1 and 6x plus 5 greater than 9x minus 4. B. 12x minus 7 greater than 4x plus 9 and 8x minus 5 greater or equals to 6x plus 5. C. 2x plus 7 greater than 6x minus 1 and 5x plus 4 greater than 3x plus 20. D. 10x minus 54 less than 4x less than or equals to 5x plus 2. So here's the solution. A. We solve the first inequality first. So we have 4x plus 5 greater or equals to 3x plus 1. Hence 4x minus 3x is greater or equals to 1 minus 5. X is greater or equals to negative 4. The second inequality, 6x plus 5 greater than 9x minus 4. So 5 plus 4 is greater than 9x minus 6x. Hence 9 greater than 3x, or x is less than 3. So we have solved both inequalities. Now let's find the common solution by drawing the number line. So the first number is negative 4. Then we draw a black dot and the arrow points to the right as x is greater or equals to negative 4. Then this is number 3. Then we draw a white dot and the arrow points to the left as x is less than 3. So from this number line, we find that the middle region is overlapped with the two arrows. Hence, the solution will be negative 4 less than or equals to x less than 3. So for B, the first inequality, 12x minus 7 greater than 4x plus 9. Let's solve this. We have 12x minus 4x is greater than 9 plus 7. Hence 8x is greater than 16, or x is greater than 2. So the second inequality, 8x minus 5 greater or equals to 6x plus 5. Hence 8x minus 6x is greater or equals to 5 plus 5, where 2x is greater or equals to 10, hence x is greater or equals to 5. So next, let's draw the number line here. So the first number is 2. Then we draw a white dot. The arrow points to the right as it is x is greater than 2. The second number is 5. Then we draw a black dot and the arrow points to the right. Okay, because it's x is greater or equals to 5. So from this number line, we find that the right region is overlapped with two arrows. Hence, the solution is x is greater or equals to 5. C. The first inequality is 2x plus 7 greater than 6x minus 1. So 7 plus 1 is greater than 6x minus 2x. So 8 is greater than 4x, hence x is less than 2. The second inequality, 5x plus 4 greater than 3x plus 20. Hence 5x minus 3x is greater than 20 minus 4, which is 2x is greater than 16, or x is greater than 8. Now, draw the number line to determine the common solution. The first number is 2, and then we draw a white dot. Now the arrow will point to the left. So for the second number, which is 8, we draw a white dot again, and the arrow points to the right. As you can see from this diagram, there is no region that is overlapped with two arrows. Hence, there is no solution for this case. For D, so we have to solve these inequalities separately. As you can see here that there are three expressions joined together with two inequality signs. Right, so we have to solve them separately. So the first inequality we can take as 10x minus 54 less than 4x. So 10x minus 4x is less than 54, which means 6x is less than 54, hence x is less than 9. Then second inequality, 4x is less than or equals to 5x plus 2. So negative 2 is less than or equals to 5x minus 4x. Hence negative 2 is less than or equals to x, or we can rewrite it as x is greater than or equals to -2. Then we draw the number line. The first number is -2. So then we draw a black dot and the arrow points to the right as x is greater or equals to -2. Second number is 9 and we draw a white dot. Then the arrow points to the left because x is less than 9. So from this number line, we can see that the middle region is overlapped with two arrows. So hence the solution for this inequality will be -2 less than or equals to x less than 9. Right now, try it yourself 5. Solve the following inequalities. A. 3 bracket 3x plus 1 less than equals to 4 bracket 2x plus 3 and 5 bracket x minus 4 less than 2 bracket 3x plus 6. B. 2 over 3 bracket x plus 9 less than x minus 1 and x plus 3 greater or equals to 3 over 4 bracket x plus 8. C. X minus 3 is less than 5 bracket 1 plus x less than or equals to 3 bracket 2 minus x. D. X over 7 less than 2x plus 1 over 2 less than or equals to 3x plus 8. You can pause the video and try to solve it yourself. Alright, here's a solution. So don't be worried about the difficulty of the inequalities. The idea is the same. So for A, 3 bracket 3x plus 1 less than or equals to 4 bracket 2x plus 3. The very first step we have to do is we expand the bracket, then we get 9x plus 3 less than or equals to 8x plus 12. Hence 9x minus 8x is less than or equals to 12 minus 3. So x is less than or equals to 9. Then the second equality, 5 bracket x minus 4 less than 2 bracket 3x plus 6. Then we expand the bracket, we have 5x minus 20 less than 6x plus 12 or -20 minus 12 less than 6x minus 5x. So the reason I want to do this is because I want to make the x term to be positive. Alright, so that I don't have to worry about the inequality signs. Then we get -32 is less than x. So let's draw this on the number line. The first number will be -32 because it is the smaller number. Then we draw a white dot and the arrow points to the right because x is greater than -32. Then the second number is 9. After that we draw a black dot and the arrow points to the left because x is less than or equals to 9. And from here we find that the middle region is overlapped with two arrows. Hence, the solution is -32 less than x less than or equals to 9. Now let's move on to D. Again, we have to solve it separately. The first inequality is 2 over 3 bracket x plus 9 less than x minus 1. Then we expand the bracket, we have 2 over 3x plus 6 less than x minus 1. So I don't like the fraction. What I will have to do is I will multiply 3 for both sides. Then simplify, we get 2x plus 18 less than 3x minus 3. Or 18 plus 3 is less than 3x minus 2x, which is 21 less than x. So the second equality is 3 is greater than or equals to 3 over 4 x plus 8. So I multiply 4 for both sides, I will get 12 greater or equals to 3 bracket x plus 8. So expand the bracket, I have 12 greater or equals to 3x plus 24. So 12 minus 24 is greater or equals to 3x, which is x is less than or equals to negative 12 over 3, which is negative 4. Then we draw the number line. The smaller number is negative 4. We draw black dots, and the arrow points to the left as x is less than or equals to negative 4. The number on the right will be number 21, and we draw a white dot, and now we point to the right. As you can see in this diagram, there is no region overlap with two arrows, hence for this case there is no solution. See, the first inequality is x minus 3 less than 5 bracket 1 plus x. So you expand the bracket first, we have x minus 3 less than 5 plus 5x. Hence, negative 3 minus 5 is less than 5x minus x. Negative 8 is less than 4x. So x will be greater than negative 2. So the second inequality, 5 bracket 1 plus x less than or equals to 3 bracket 2 minus x. Expand the bracket, we have 5 plus 5x less than or equals to 6 minus 3x. So 5x plus 3x is less than or equals to 6 minus 5. 8x is less than or equals to 1. Hence, x is less than or equals to 1 over 8. And now, we can start to draw the number line. The first number on the left is negative 2. Then we draw a white dot. Arrow points to the right as x is greater than negative 2. Then the next number is 1 8. So we draw a black dot, and the arrow points to the left. So from this number line, we find that the middle region is overlapped with two arrows. Hence, the solution for this example is negative 2 less than x less than or equals to 1 over 8. So for d, x over 7 less than 2x plus 1 over 2, we cross multiply. We have 2x less than 7 bracket 2x plus 1. Expand the bracket, we have 2x is less than 14x plus 7. So negative 7 is less than 14x minus 2x. We have negative 7 is less than 12x. Hence, negative 7 over 12 is less than x. Then the second inequality, 2x plus 1 over 2 less than or equals to 3x plus 8. So move the 2 to the right hand side. We have 2x plus 1 less than or equals to 2 bracket 3x plus 8. Expand the bracket. We have 2x plus 1 less than or equals to 6x plus 16. Hence, 1 minus 16 is less than or equals to 6x minus 2x, which is negative 15 less than or equals to 4x. So negative 15 over 4 is less than or equals to x. Or change to the proper fraction, we have negative 3 and 3/4 less than or equals to x. Alright, now we can start to draw the number line. So the smaller number, so you have to be careful with the negative numbers here. It should be negative 3 and 3 over 4 because this number is smaller than negative 7 over 12. So after that, we draw a black dot, and the arrow points to the right because it is x is greater or equals to negative 3 and 3 over 4. Then the second number is negative 7 over 12. Then we draw a white dot. The arrow points to the right as well because x is greater than negative 7 over 12. So from here, we find that the right region is overlapped with two arrows. Hence, the solution is negative x is greater or equals to negative 7 over 12. Alright, so this is the last topic for today's lesson, finding largest and smallest values of variables. So let's look at example 6 so that you know the idea clearer. Given that 2 less than or equals to x less than or equals to 8 and negative 2 less than or equals to y less than or equals to 2, where x and y are integers. Find 1. The largest possible value of 5x plus 2y. 2. The smallest possible values of 5x minus 2y. 3. the smallest possible value of 5x over 2y, and 4, the largest possible value of 2x squared minus y squared. So to answer this type of question, here are two tips for your reference. Tip number 1, we'll always try the extreme values if you want to find the largest possible value or the smallest possible value. So for this case, the x is in a range of 2 to 8 inclusive. So we can think about or consider the number 2 and number 8 for the x value. So for the y, we can consider as negative 2 and 2 as it is in a range between these two numbers and inclusive negative 2 and 2. Tips number 2, sometimes we have to consider 0 as well, especially when you find that the variable is in a range from negative to positive. So for this case, y is in a range from negative 2 to 2 inclusive. Hence, we can consider extra one more value for y, which is 0. Okay, so now let's look at the solution. For number 1, we want to find the largest 5x plus 2y. So from here, we can see that the operation is addition, and we want the value to be the largest. So now we choose x equals to 8 and y equals to 2. Okay, so for this case, it becomes 5 times 8 plus 2 times 2, which is 44. Number 2, the smallest 5x minus 2y. So for this case, the operation is minus in order to get, they want the smallest value. So in order to get the smallest value, the first term must be smallest. So let's choose x equals to 2. Okay, so then it becomes 5 times 2. Now look at the second term. It must be largest because we want to get, in order to get smaller value, the smallest number minus the largest number will give us the smallest possible value. Alright, so from here I will choose y equals to 2 because 2 is also the largest possible number for y. Hence, it is minus 2 times 2. So the answer is 6. Number 3, smallest 5x over 2y. So for this case, the operation is division. The value we want is the smallest, and y cannot be 0. Alright, so now for this case, we have to consider all the possible cases. So x will be 2 and 8, y will be negative 2, 2. So now from here, the expression we have is 5x over 2y. So if x is 2, y is negative 2, then the value becomes negative 5 over 2. So repeat the same process for the next number. X is 2, y is 2, then 5x over 2y will be 5 over 2. Next, if x is 8, y is negative 2, then 5x over 2y will be negative 10. Then lastly, so 8, when x is 8, y is 2, hence 5x over 2y will be 10. So from this table, since you want to find the smallest possible value, hence the answer is negative 10. So the smallest possible value for 5x over 2y will be 5 times 8 over 2 times negative 2, which is negative 10. So number 4, we want to find the largest possible value for 2x squared minus y squared. So for this case, the operation is square and minus. So we want the value to be the largest. Alright, so we have to build a table. For the x, the possible value will be 2 and 8. For the y, it could be negative 2, 2 or 0. Okay, so this is the expression that we want, 2x squared minus y squared. So when x is 2, y is negative 2, we'll get 4. So repeat the same process for the other values here. So the second will be 4, the third one will be 8, the next one will be 124, 124 and 120, 128. Okay, so from here, since you want to get the largest value, so 128 will be the answer. So largest 2x squared minus y squared is 2 times 8 square minus 0 square, which is 128. Alright, now try it yourself. 6. Given that x and y are integers such that x is between -2 inclusive and less than 5, and y is between 1 and 8 inclusive, find 1. The least possible value of x squared minus y. 2. The greatest possible value of y squared over x plus 3. So you can pause the video and try to solve it yourself. So here's the solution. Here, let's consider the extreme values to consider. So for the x, we'll consider -2, 0, and 4. For the y, we'll consider 1 and 8. So we want to find the least possible value of x squared minus y. The operation is square and minus. Okay, so the value we want to get is the least value. So in order to get the least value, the first term must be the smallest. So for this case, we choose x equal to 0. The second term will be the largest. Hence, we choose y equals to 8. So now the least possible value of x squared minus y will be 0 squared minus 8, which is -8. So number 2, the greatest possible value of y squared over x plus 3. So for this case, the operation involved is the square and division. And we want to get the greatest possible value for the whole expression. So the numerator must be the greatest. So for this case, we choose y equals 8. Then the denominator is the least. So we will choose x equals to -2. Now substitute these values. We will get x squared over -2 plus 3, which is 64. Alright, that's all for this lecture. Thanks for watching. Do you like this video? Don't forget to press the like button and share it with your friends. Do you have any questions or thoughts to share? Feel free to write it down in the comment area. Do you want to discover the secrets of A1 student's mind? You can get this book that I have written in 2 versions, either in Kindle or in paperback. This book is sold in Amazon. So do check out at the description area for the link. Alright, until then, see you in the next video.